Most enterprise search failures do not happen because the AI model is weak. They happen because the system found the wrong information. A user may ask, how do I unlock my account? And the system may return a document about access reviews. Or a customer may ask, how do I dispute an invoice? And the chatbot might pull up billing setup instructions. The words look related, but the intent is wrong. That is the problem that embeddings are designed to help solve. By the end of this video, you'll see what embeddings actually are, why they make retrieval much smarter than plain keyword matching, and why retrieval can still fail even when the embeddings are good. And we are not just going to talk about it, we are going to use this live demo to literally watch phrases move around in meaning space. Welcome to Scovia, where we make AI concepts feel like everyday ideas. Let's start with the core problem. Traditional search mostly looks for word overlap. That works well when the query and the document use the same language. But systems in the real world are messy. People ask for the same thing in many different ways. A keyword system may treat those as different. A good retrieval system should understand that they are closely related. And that is where embeddings come in. Embeddings give us a way to represent meaning numerically. So similar ideas can be found even when the wording changes. This is the foundation of modern semantic search, retrieval, and most RAG systems. Here's the simplest way to think about it. An embedding is a list of numbers that acts like a coordinate for meaning. Each phrase gets turned into a point in a high-dimensional space. We can directly look at hundreds or thousands of dimensions. So this demo projects them down into a two-dimensional map so we can build intuition. But how does one decide which phrases or words should be converted into which numbers? That is a much deeper topic which we'll discuss in a separate dedicated video. For now, assume that there is a solid mechanism which is able to produce the right list of numbers for each word or phrase or a sentence that you enter. So each of these phrases is converted into an embedding. You can see a preview of the numbers here, but the numbers themselves are not the point. What matters is the relationship between them. If two phrases have similar meaning, their embeddings tend to land closer together. If the meanings are different, they drift apart. Now look at the map. Reset employee password and unlock my work account should sit near each other. Request vacation approval and submit PTO request should also cluster. And something like office printer jam, that should land further away. That is the big idea. Embeddings help the system to compare meaning, not just wording. So why does this matter for enterprise search? Because retrieval is really a matching problem. The system takes a user query, converts it into an embedding, and then looks for the stored pieces of content whose embeddings are closest. That means a user can ask, how do I get back into my account? And the system can still retrieve a document titled Password Reset and Account Unlock Procedure, even though the exact words do not match. That is why embeddings are powerful. They let retrieval generalize across paraphrases, synonyms, and natural variation in language. This matrix here is another way to see the same thing. Darker or stronger similarity scores mean the phrases are closer in meaning. So retrieval works when closeness in the embedding space is a good proxy for usefulness. And in many real search systems, that is already a huge improvement over plain keyword search. Does this mean that the retrieval problem is solved for good? Turns out that's not the case. Embeddings-based retrieval also fails. Because being close in meaning is not always the same thing as being the right answer. Here are three simple ways it can go wrong. First, the system may look at the wrong piece of text in a document. Maybe the answer is split across different parts of the document. Maybe the section it finds sounds related but misses the actual instruction. Second, similar does not always mean useful. A query about invoice disputes might pull up something about billing issues. That sounds close, but it may still be the wrong help article. Third, the source itself may be bad. If the knowledge base is outdated, messy, or contradictory, retrieval can still return the wrong thing. So, embeddings do improve search, but they do not guarantee that the system has found the best evidence. So, what should enterprise teams do? Not just use embeddings, but use them as one part of a retrieval system. Good systems of retrieval usually combine semantic search from embeddings, keyword or lexical matching, metadata filters, smart splitting of the text, re ranking, and evaluating on real user queries. Keyword search and embeddings are not enemies. You don't have to choose just one of them. In many serious systems, hybrid retrieval works better than either one alone. Because search is not just about finding related language, it is about finding the right information for this user, in this context, for this decision. That is a much harder problem. And this is why retrieval is a systems problem, not just an embeddings problem. I hope this helped you understand how embeddings work. Please subscribe to Scovia and as always, stay curious.